Welcome students. In this short video, I want to introduce you to efficient algorithms, COMP526. This is a 11.7 module, so you would usually do this in your MSc program or in the fourth year of your MH. It happens in the first semester in the fall. This is a theory module in theoretical computer science. So what I mean by that is that we'll prove theorems about the performance and the correctness of algorithms, and we'll do that in a mathematical model of computation, which formalizes what computers do and how costly that is. And the main benefit of that is that we can prove lower bounds, which are impossibility statements that no algorithm can do a task faster or cheaper than a certain specific threshold. I hope to show you algorithmic techniques that have wide practical impact in doing that. So we'll pick specific examples that are chosen to be among the most useful ones. We'll do this on mostly sequence data, anything one-dimensional, and we'll specifically look at how to find pattern in sequence data, how to find specific patterns, how to sort sequence data, how to prepare it for very fast access by pattern searches if the data does not change often, and we'll look at data compression. Orthogonally to that, we'll also look at parallel algorithms to speed up any of these processes. The content is split into these units covering roughly one week of lectures, at least on average. If you want to check out in more detail what these are, please go to the module website, which has past iterations of the module, and the content is only slowly evolving, so this should give you a good picture of what the module will be like. Why would you want to choose COMP526? I think there's lots of lovely, insightful tricks. If you enjoy math puzzles, you should enjoy this module. There's beautiful and deep connections between some of these topics, even though they superficially at first sight don't seem to relate to each other. I will try to start from basics and catch you up, even if you're not coming from an undergraduate computer science degree, or if there's been a bit of time since you've last seen algorithms. But then we'll go to the cutting edge of research in some of the topics and dig deep on those. In terms of how we will run the module, there will be standard lectures accompanied with in-class questions, just to keep you awake and engaged. There'll be tutorials running next to that, where you can do some practice questions. We'll have an online Q&A running where you can ask your questions and hopefully answer other students' questions. And in terms of assessments, apart from the final exam at the end, we will have throughout the term, we'll have 2 programming puzzles for you to submit, and we'll have class tests which are split into several tiny tasks just to test your understanding and collect a little bit of the mark throughout the term. I want to close with a comment on the philosophy of this module. I'm not going to read out the comics to you. I'll leave you to pause the video and do that. The idea is that we focus on the eternal universal truths of algorithms, not so much on hacking and making things fast in a specific setup, but on the things that have stood the test of time and will remain valid throughout the decades to come by abstracting a little bit from the reality of computers that we've built today. Again, if you want to find more information, check out the module website. I have previous iterations of the module archived there, and you can get a good picture of what the module looks like during the term from the website. Thank you and hope to see you soon.